when I'm recording a long recording and I'm all by myself and nobody else is in the classroom, GoToMeeting shuts down my thing at some point part of the way in. So it's a little irritating to me sometimes, but since there wasn't anybody else in the classroom with me, it thought that I was like not really there, I guess. Okay, so let me start 21. I'm just going to start it kind of from the beginning with the theory of it. It's still written down here. Here's our problem. When is this less than 5? First, we establish the fact that x cannot be 3, because that would give me a denominator of 3. It would not work. Then we say, when I multiply both sides by the common denominator of x minus 3, if x minus 3 is positive, and if x minus 3 is positive, then that means that x is bigger than 3. If x is positive, then it works just like it is with the less than sign there, blah, 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 x is greater than 4. So what I'm saying here is when x is greater than 3, it works when x is greater than 4. Okay, so basically we have two criteria. X has to be greater than 3 in order to consider it, and then it has to be greater than 4. So really x greater than 4 is what we're talking about here. My criteria don't contradict each other. X has to be greater than 3. Okay, it's greater than 4. Yeah, that works. On this problem, if x minus 3 is less than 0, then x has to be less than 3. And this one says when x is less than 3, it also has to be less than 4. But my bigger criteria here is I'm only looking at x less than 3. And the fact that it has to be less than 4 means that this is the criteria that I'm going to use. Again, let's think about it this way. This problem says I'm only considering when x is greater than 3, and the answer is that x has to be greater than 4. So greater than 4 is my most stringent requirement, so x greater than 4 in a sense is the winner. For this problem, I'm only considering if x is less than 3, and the requirement is that x has to be less than 4, so the more stringent of the two is this one. So if I'm going to put these on the same number line, what we're saying is x has to be less than 3, or it also works if x is greater than 4. So our interval notation will look like this: from negative infinity to 3, union from 4 to infinity. Notice there is not an equal sign on here, it's only less than, so I have parentheses and not closed brackets. Almost done. Everybody hang in there. Number 28 says that an absolute value of 2x plus 1 is greater than or equal to 11. Think of an absolute value is a distance. If I drive from my house to your house, maybe it's 17 miles. From your house to my house is still 17 miles. Absolute value is always positive because it's a distance. Odometers never go backwards. So what we're saying is that from some place, the distance is more than 11 away. So it's somewhere out there. It's at least 11, maybe more than 11 away, and at least 11, maybe more than 11 away. When you see an absolute value greater than, you need to think about it looking like this. The distance from my house to your house is more than 11. Well, I don't know from my driveway, do I turn left or right, but I sure know I have to go more than 11 miles to get to your place. So when you think of it like this, the way you set up the equation, you end up with two equations, because the value of 2x plus 1 might be more than 11. The value of 2x plus 1 might be less than or equal to a negative 11. When you take it out of the absolute value bars, you've got to use positive and negative to tell you distance. So this is a positive 11 away in the positive direction. This is 11 away in the negative direction. It's got to be further away than that or more away than that. Okay, once you set up the equations, the rest of it's simple. This is what you have to remember. It's less than or equal to a negative 11 because it's that way. Greater than or equal to a positive 11 is this way. So 2x greater than or equal to 10, x greater than or equal to 5, 2x less than or equal to negative 12, x less than or equal to negative 6. If you think about these two solutions on a number line, less than or equal to a negative 6, greater than or equal to a positive 5, sure enough, the shape of the answer is exactly what I was expecting it to be, and our interval notation would be negative infinity to negative 6 with a bracket, united with a bracket of 5 to positive infinity, parentheses. And it's all about the fact that absolute value means distance, so it's 11 away, either 11 in the positive direction or more than that, or 11 in the negative direction or less than that, because when we move to the left on a number line, we're always talking about a negative direction, negative amount. I think I just did the wrong. Look at me, I mixed. No, sorry, this is number 29. Let's do 28 next. Sorry about, oops. Okay, sorry about that. I did these backwards. This is 28. I did 29. I wrote the problem down wrong. Did 29 first. 28 is the absolute value of 2x minus 5 is less than 9. Again, what that means is, here is my value. The distance is less than 9. So if we go 9 up this way and a distance of 9 that way, the answer is somewhere in the middle. It's no further than 9 away. I don't know which way to go, but I know it's not any more than 9 away. So the 2x minus 5 has to be between a 9 and a negative 9. When you take it out of the absolute value bars, then you have to consider direction. Negative 9 would mean this one, positive 9 to the right. Once you write the equation, it's very simple. And again, the point is 2x minus 5 is bound on top and bottom by a distance of 9, 9 to the left or 9 to the right. When I add 5 to both of these, right, when you add 5, be careful, you've got signs involved, divide everything by 2. X is between a negative 2 and a positive 7. That's what this graph looks like. Again, the shape of the graph is exactly what I expected it to be, because the distance is somewhere between two outer boundaries. And if I put it in interval notation, it looks like this. Notice on 28 there is no equal sign, so I have all open circles and parentheses. Okay, and again, I did 29 first and then 28, so the next one I'm going to do is 30. And just in case you're fast forwarding through the recording and confused, I just did 27 and then 29 and then 28 and now 30. So if you're looking for 29 and you just came from 28, go back before 28. I just misread my paper, my notes. All right, last one finally. Absolute value of 3x plus 7 is less than 0. Stop and think about that for me a minute. How can a distance be less than 0? It cannot. So that answer is a very simple no. No, you can't have a distance between two things be less than 0. It could at least be equal to 0, but you can't have a distance be less than 0, which is why there's no solution for that problem. And that, my dear friends, is a very long review over a lot of material. Hopefully this has been helpful. Thanks.